From our point of view, human life might seem like it's just how things are. We live in modern societies, buy food, cook meals, and sleep in solid homes. But this kind of life actually takes a lot of intelligence. Building a house, for example, requires not just design skills, but also the ability to use complex tools and work with others. Coordinating with people based on shared, abstract rules is a remarkable feat of intelligence, something no other creature on Earth is capable of. This raises an interesting question. How did we get so smart, and why are we so different from other life forms on Earth? While our origins are still mostly a mystery, there are several scientific hypotheses that give us a plausible picture of how humans evolved. The laws of evolution are actually pretty simple. In any environment, most organisms don't survive long enough to reproduce. Some do, and their offspring carry their genes forward. Over time, this process repeats itself, survival and reproduction, gradually shaping organisms to better fit their environment. In harsh environments, animals evolve unique traits to help them survive. For example, goats can climb cliffs to escape predators and find food, while camels can store water for a longer period in the desert. So, why did humans evolve such advanced intelligence? To answer that, we need to look at the key difference between intelligence and physical ability. The truth is, you don't always need to be super smart to survive. You might just need to enhance your physical abilities. For example, in an environment with scarce food, boosting your digestive capacity to process different types of food could help. In a world with predators that have powerful teeth, developing tougher skin could be a survival advantage. In fact, many animals have evolved in ways like this. Then, why did humans take a different route, focusing on evolving intelligence rather than just enhancing physical abilities? Intelligence has a unique advantage over physical abilities. When environmental changes happen slowly, organisms have time to adapt their physical traits to survive. For example, if a region is gradually turning into a desert, camels can slowly increase their water storage capacity. But if the environment changes suddenly, they don't have time to evolve physically. They need to find a solution right away or face extinction. High intelligence gives creatures the flexibility to solve problems on the spot. If our environment suddenly becomes a desert, for example, we could likely find ways to fetch and store water in the short term by using our human intelligence. So, here's a hypothesis. Maybe sudden environmental changes played a key role in why humans became so smart. In his book Origins, astrobiologist Louis Startnell presents a scientific theory that links the evolution of human intelligence to shifts in Earth's topography and climate. Humans, or Homo sapiens, are surprisingly low in genetic diversity. In fact, different human populations living on opposite sides of the Earth have less genetic diversity than chimpanzee groups separated by just a river in Africa. This suggests that humans evolved together in a small area, gradually shaping into what we are today and then spread out across the planet. Most scientists now believe that humans evolved as a group in East Africa. The unique environmental conditions of the region likely played a huge role in our revolution. In particular, the rapid drying of East Africa was a critical factor in the emergence of humans. Over the past 50 million years, the Earth has been cooling on a global scale despite all the talk about global warming today. One hypothesis is that changes in the Earth's topography have played a big role in this cooling. The Earth's surface is made up of moving plates, and when these plates collide, they push up, creating massive mountain ranges. About 50 million years ago, the Indian and Eurasian plates collided, forming the towering Himalayas. The rocks that were lifted up then reacted with carbon dioxide in the atmosphere to create carbonic acid, which dissolved in rivers and flowed into the oceans. This process helped remove a significant amount of carbon dioxide from the atmosphere, reducing the greenhouse effect and cooling the planet. While there's still some debate about whether this hypothesis is entirely correct, it's clear that carbon dioxide levels in the atmosphere have decreased over time. As the greenhouse effect weakened, temperatures dropped, leading to less evaporation of ocean water, and the earth became drier. In addition, the Himalayas and the Tibetan Plateau created strong monsoons in India and Southeast Asia, causing heavy rainfall in those areas while drying up nearby East Africa. Meanwhile, Australia and New Guinea moved to block ocean currents, limiting the flow of warm water into the Indian Ocean, which also contributed to East Africa becoming drier. Not only the macroclimatic and geographic changes, but also the shifts in East Africa's geography itself affected East Africa's rapid drying. Today, East Africa is home to what's called the East African Rift System. In the past, Africa and the Arabian Peninsula were one continent, but then they split apart, forming an ocean in between. Now, there's a vast strip of land running through Ethiopia, Kenya, and the eastern side of the Congo that's still being torn apart. This rift is sinking into deep valleys, and around those valleys, cracks in the Earth's surface are releasing material from deep within, creating towering mountain ranges. For example, Mount Kilimanjaro, Africa's tallest mountain, is located in this region. Originally, East Africa was a flat land covered in dense tropical forests. But as the land began to tear apart, it transformed into a landscape with deep valleys and towering rocky mountains. As these high mountains rose along the East African coast, they blocked rain clouds coming from the ocean. This change in landscape made many areas even drier. Forests gave way to vast savannas. Our ancestors, like other primates, mostly lived in trees where they could safely escape predators and gather fruit. But as the trees gradually disappeared, the need to hunt increased. The savanna offered little fruit but was full of animals like antelope and zebras, which were easier to hunt. As the East African rift continued to tear apart, hunting likely became more about intelligence than physical strength. The region's landscape ranges from flat valley floors to towering mountains in a small area. Our ancestors, who were agile on their feet, were able to navigate this steep terrain better than many other animals. This gave them an advantage, allowing them to stay relatively safe from predators despite their lack of physical strength, and to use the rock terrain to their advantage when hunting. In this process, they likely developed the ability to work together to hunt, perhaps by luring together animals into areas where they couldn't easily escape. The hypothesis is that as East Africa's landscape rapidly changed, it created a more complex environment. Our ancestors, already somewhat more intelligent than other animals, quickly adapted and developed even more intelligence to make use of this complexity. The simpler the environment, the less the benefit of intelligence. But the more complex the environment, the more intelligence helped them survive and thrive. Another interesting hypothesis is that the so-called amplifier lakes in the East African Rift System made the already unique environment even more volatile. The flat bottoms of the valleys here form lakes as water flows in from the surrounding high mountains. These steep mountains tend to get a lot of rain, while the lakes below experience strong evaporation due to the intense heat. This unique combination of contrasting environments creates what are known as amplifier lakes. These lakes rapidly rise in water level when the climate is rainy and cloudy because the mountains catch all the rain. On the other hand, when the climate becomes drier, the lakes shrink just as quickly because of the strong evaporation. Amplifier lakes in the East African Rift System are more sensitive to climate changes than other lakes anywhere else on Earth. On the other hand, the Earth experiences periods of extreme climate changes about every 800,000 years, driven by shifts in its axis of rotation and orbit around the Sun. During these times, the amplifier lakes of the East African Rift system would have undergone incredibly rapid transformations, quickly turning into lush, water-rich forests and just as quickly drying up again. In this constantly changing environment, our ancestors would have faced intense evolutionary pressure to survive by developing intelligence. The last 3 periods of rapid climate change occurred around 2.7 to 2.5 million years ago, 1.9 to 1.7 million years ago, and 1.1 to 0.9 million years ago. These periods coincide with the emergence of new, more intelligent human species, suggesting that during each phase of rapid environmental change, humans became smarter. The more interesting part of this hypothesis is the speculation around the emergence of Homo sapiens. Actually, Homo sapiens wasn't the only intelligent hominin. There were other species with notable intelligence, but we were the smartest of them all, and eventually, we beat others and took over the planet. Then, why Homo sapiens became smarter than other hominins? When the environment of East Africa became scarce, various hominins began to migrate to other continents. Homo erectus, for example, is believed to have left Africa around 1.8 million years ago, eventually reaching as far as China. Some of them evolved into Neanderthals in Europe. In contrast, Homo sapiens is thought to have evolved from the Homo erectus that remained in East Africa about 300,000 to 200,000 years ago. This leads to a fascinating hypothesis. Maybe we became smarter than other hominins because we stayed in the highly volatile environment of East Africa. The humans who migrated to more stable environments likely didn't face the same evolutionary pressure to rapidly increase their intelligence, since their abilities were already enough to handle relatively mild environmental changes. On the other hand, humans who remained in East Africa, where environmental changes were much more rapid, had a strong advantage in becoming smarter. As a result, our intelligence grew, and we eventually spread across the planet, having a competitive edge over other human species. We've been looking at scientific hypotheses about the emergence of humans, and I've been reflecting on how this science story serves as a powerful metaphor for human society. There's an idea that science and technology tend to advance rapidly during times of turbulence, like the development of biochemical and nuclear technology during wartime. Moreover, times of frustration or crisis often lead to the most significant personal growth in our lives. It seems to be a common pattern that rapid environmental changes spark powerful transformations, whether in a species, a society, or an individual. However, the problem is that while those who survive these fluctuations often become stronger, many do not survive. This holds true in evolution, in society, and in our own lives. There's plenty of room to grow if you make it through, but many others won't make it through, and they don't get the chance to become wiser or stronger. So the key question is, how can I survive? How can I use a fluctuating situation as a springboard to move forward? I believe these questions are the lessons we can learn from the origin of humans.